Good morning. Hi, so we're back. This is the beginning of Unit 4. Unit 4 is going to cover chapters 6 and 7 in your textbook, and we're going to begin today with chapter 6, which is understanding and converting percentages. And then we're going to talk about business percentages or percentages with business applications. So, here we go. So in order to understand and convert percents, we need to understand that percentages are primarily a way that businesses represent change when they're talking about very different variables. We may talk about the percent of customers increasing or decreasing, the percent of sales increasing or decreasing, the percent of markup on a particular item. So what we're going to practice today is the different conversions, but the main rules are thus. If we're converting percentages to any other modality, decimals, fractions, whole numbers, whenever we're taking the percentage symbol off, we want to divide by 100. So 28% is also written as 28 divided by 100, or 28% divided by 100%. In this way, the units or percentages cancel, and we're left with 0.28. Similarly, big red box. Similarly, if we have 159% and we want to get rid of the percent, convert it to any form other than percent, we're going to do 159% divided by 100%, essentially canceling out those percent signs. This is going to give us a 1.59, which is the percent as a decimal. 0.8% looks like a difficult number. In fact, to many of you, this will already look like it is a percent. It is not. I know that this hasn't been converted because the percent sign is still on there. And because the percent sign is still on there, I'm going to go ahead and do 0.8% divided by 100%. That's how I eliminate or get rid of the percent symbol. This is going to give me 0.008 as my final answer. Now, if you look at all three of these answers, you will notice that when you divide by the 100%, the percent sign drops, and essentially your decimal point has been moved 2 places over to the left. So one of the things we sometimes say as a shortcut when you're eliminating a percent is to simply move the decimal point 2 places to the left. If we are going to convert any form, a decimal, a fraction, etc., to a percent, what we want to do is multiply by 100. In effect, we're putting the percent symbol on the number. We're putting it on the end of the number. So we want to multiply by 100. In that manner, 0.75 as a percent is rewritten as 0.75 times 100%, which works out to be 75 with the percent sign on it. We're putting the percent sign on when we multiply by 100%. There we go. 0.0115 is not a percent. I know it's not a percent because the percent symbol is not on the number itself. To put the percent symbol on and mark it as a percent, I need to multiply by 100%. This gives me a 1.15%. 3. This one looks like it is already a percent. It is not. I know it is not a percent because it does not have the percent symbol on it. In order to convert it to a percent and put the percent sign on the number, I will need to multiply by 100%. This gives me 300%, which is the same as 3 times a number. And I have 3 as a percent is 300%. Now, what do all three of these have in common? When you put the percent sign on, you move the decimal point 2 places to the right this time. Okay. All right. We want to be able to convert percentages to fractions. Now, since we're converting the percent to another format, such as a fraction, we want to divide by 100%. That takes the percent sign off or away. The division takes the percent sign off or away. Now, what's difficult about fractions is we have to remember that dividing by 100% is the same as multiplication by the reciprocal, or multiplying by 1 over 100%. The rule of fractions. So here's what that looks like. If I had 7% and I want to convert this to a fraction form, I'm going to do 7% divided by 100% because I'm taking off the percent sign, except I'm going to write it in fraction form, which is 7% times 1 over 100%. This is going to give me 7 over 100. 7 times 1 is 7, 1 times 100 is 100. My percent signs would cancel out, leaving me with just 7 over 100. Similarly, if I have 21 2/3%, this is a percent. It is what's known as a fractional percent, and I want to convert that to just a fraction. So I'm going to follow the rules of fractions. I'm going to take 21 2/3, and I'm going to convert that to an improper fraction. I'm going to go from the mixed number it is, the mixed number percent that it is, to an improper fraction. So 3 times the 21 is 63. Excuse me. When I add 2, I get 65. So this is 65 over 3 as a percent. And I'm going to divide that by 100%. Now, dividing by 100% is the same as multiplying by 1 over 100%. So I have 65 over 3% times 1 over 100%. This is going to give me 65 over 300. 65 times 1 is 65. 3 times the 100 is 300. And so I have 65 over 300. What I need to recognize here is that this will cancel. I can eliminate a 5 at least out of both of those. 65 divided by 5 is 13, and 300 divided by 5 is 60. So that gives me a fraction of 13 over 60. Where did the percent sign go? When we divided by 100%, it canceled with the percent sign in the original number. So we no longer have the percent sign needed. Right? Okay, one more. 4/7 as a percent. This is 4/7 of a percent. So this is less than 1%. Okay? So to convert this number from a percent that is a fraction to just a solid fraction, no percent sign at all, I want to eliminate the percent symbol by dividing by 100. So I'm going to take 4/7% and I'm going to divide by 100%. That is the same as multiplying it by 1 over 100%. Because they are fractions, we will multiply by the reciprocal. This gives us 4 times 1, which is 4, over 7 times 100, which is 700. 4 over 700. I need to recognize that both of these are divisible by 4. If I divide 4 by 4, I get a 1, and if I divide 700 by 4, I get 28. So as a fraction, 4/7 of a percent is 1/28. Okay, now we're going to go the other way, and we're going to convert straight up fractions to percentages. Now, we're going to leave our percentages in fraction form where appropriate, and we want to recognize that when we have a fraction, just a straight fraction, and we convert it to a percent, we're putting the percent sign on, so we are going to multiply by 100. So 1/8, to convert it to a percent, would be 1/8 times 100. This is going to be 1 times 100% over 8 times a 1 or 100% over 8. Now, 8 goes into 100 12 times with a remainder of 4. So this becomes 12 4/8 with the percent sign on it. And simplifying that a bit further, we get 12 1/2%. I have converted the fraction of 1/8 to a percent of 12 1/2. Now, I have 7 over 245 as my fraction. I purposefully made this one a little bit awkward or difficult, but it's the same process. Our numbers are just a little bit harder. So we're going to take that 7 over 245, which is just a straight up fraction right now, and we are going to multiply it by 100% to convert it to a percent. So 7 over 245 times 100%. That's going to be 7 times the 100% over 245 times 1, or 700 over 245 as a percent. I need to recognize at this point that I can simplify it. Both the 700 and the 245 are divisible by 5, so that's going to give me a 140 over 49 as a percent. At this point, I know that 49 is 7 times 7, and 7 will also go into 140. So I'm going to reduce both of these by 7 again. And when I do that, I see I have 20 over 7. This is my improper fraction. I want to convert it to a mixed number percent. So 7 goes into 22 times with a remainder of 6. So this becomes 2 6/7%. All right, last one. 2 2/3 is just a fraction right now. We want to convert that to a percent. So we are going to, once again, multiply by 100. Now, on a little bit of a side note, I do want you to sort of recognize that since this is already a whole number, I do already have a whole unit 2 in here, that this percent is going to be more than 200%. Since it's not a 3, it's going to be less than 300%. 2 2/3 as a straight up multiplier is between 2 and 300% of the original number. What exactly? Well, I'm going to take that 2 2/3 and I'm going to multiply it by 100%. And like I did before, I'm going to take the mixed number and convert it to an improper fraction. So 2 2/3 would be 3 times 2 is 6, plus 2 is 8. So this would be 8 over 3 times 100%, or 800 over 3 as a percent. Now when I divide that through, 3 goes into 800, 266 times, with a remainder of 2. So this will be 266 2/3%. Note that this is between 200% and 300%. Now, on the original PowerPoint, which you can find on Blackboard in this same folder where you found this video, there is an entire slide with practice where we can go through this and you can practice your calculations to make sure that you are getting the correct answers. Now, I do work through a couple of them, in particular the fraction ones, so you have an idea of where that's coming from. But I do not work through all of them, right? That's all we have for the first section of Chapter 6. There is more practice in the review exercises for Chapter 6, Section 1. For the second section, we're going to use the percent formula to solve business problems. So when we do that, using the percent formula to solve business problems, we want you to recognize that the base is the word that we use for the whole or total, that the base will always represent 100%. As a pro tip, the base is often, but not always, preceded by the word of. The portion is a part of the whole or the total. It can be larger than the whole, particularly when you have something like 300%, and it will also be smaller than the whole, like 20% or 30%. The units of the portion will always be the same as the base, and it will often have a qualifier. In other words, we will want to know the portion of girls only, or the portion of cars that are blue. The portion, as your pro tip, is often near the word is. Most often it's after the word is, but sometimes it's before it. As in, the answer is 60, 60 is the answer. We can say that both ways. So it's near the word is, not always before, but sometimes after. Okay? The last piece is the percentage. The percentage is the portion when compared to a very specific number, and that's 100. Percent is always out of 100. You will know a percent by the percent sign, which is actually a 100, in case nobody ever told you that before. The percent symbol is just sort of a warped 100. That's a 1, which is your diagonal, and then the 2 zeros on the 100, one above and below. The other thing is that the word percent, per meaning out of, and cent meaning 100, as in 1 cent is 100 pennies. You can solve business problems using the percent equation. This is the most frequent one. This is the one we'll be using most of the time. But you can also use a percent proportion. If you took a pre-algebra course, you probably use the percent proportion most often. I'm not going to use that in this particular section, although we do use it in several others. Now, if you've used the percent proportion, I'm not trying to mess you up here. I'm going to teach a different method, but you feel free to use the percent proportion as you see fit. You may know this as is over of equals percent over 100. Right? Okay. In order to help you with the percent equation, your textbook uses a method called the magic triangle. I love this. I love it because it's sort of quirky, not because it's necessarily my favorite thing in the whole wide world. But here we go. So the magic triangle looks like this. It's a triangle that's split into 3 sections. On the top you see P. This P stands for the portion. The R stands for the rate, which is actually the percent. And the B stands for the base or the total. Okay? So here's what you do. When you're looking for the portion, which is the part or the smaller amount of the total, you simply put your hand or the back of your eraser or your pencil or whatever, a thumbtack, on top of the P for portion. And then you see that what's left is the R and the B, and they're on the same level. So this becomes rate times base. And you have your first formula from the magic triangle, which is that the portion is equal to the rate times the base. Now, if what you're looking for is the rate, you put your lovely little hand or finger over the rate, and you're left with the portion on top of the base. And this tells you exactly what to do. The rate is the portion divided by the base. Similarly, if what you're looking for is the base, you put your finger or the back of your pencil on top of the B for base, and you're left in the magic triangle looking at the portion on top of the rate. So in order to find the base, you take the portion and divide it by the rate. For those of you with a strong algebra background, you simply recognize that the bottom two, the rate is the portion over base and the base is the portion over rate, are simply rearrangements of portion is equal to rate times base. So I don't often use all 3 different formulas. I fairly often just use the top one and then divide as to what I need to find. But you do you as we go through this. All right, so we're going to do a few problems here. When we have to solve for the portion. What is the portion if the base is $400 and the rate is 12%? Recognizing from the magic triangle that portion is equal to the rate times the base. And keeping in mind that for percent equations, our rate will always be the percent in decimal form. What we'll need to do now is substitute values into the formula. Portion is equal to rate times base. Using that our rate is 0.12, which is 12% as a decimal, and our base is 400. we will have P is equal to 400 times 0.12, which is 48. This gives us a portion of 48, or 48 is 12% of 400. Solving for the rate, PetSure orders 560 fish tanks, but only 490 were delivered. What percent of the order is missing? Since I have to find the percent, I know that is the rate. And using the lovely magic triangle, I know that rate is equal to the portion over the base. Keeping in mind that my rate answer will be a percent in decimal form, I'll then substitute my values. I need to find the portion that is missing, which will be 560 minus 490, or 70 fish, over the base, which is 560. So my rate is 70 divided by 560, or R is equal to 0.125. This is your percent as a decimal. So I'll want to multiply by 100 to put the percent sign on, or 12.5%. When we have to solve for the base, Dick's reports that 32% of all shoe sales last month were Nikes. Dick's Nike sales alone, we know, were $4,000. What was the overall total shoe sales? Well, we've been given not all of the total, not the 100%, but the portion, that $40,000 is the portion. And we know that that's 32%. So we're trying to find the base, or the total. The base is the portion divided by the rate. Keeping in mind, again, we want to use rate as the percent, as a decimal. Now, we're going to substitute our values in, noting that our portion is 40,000 and our rate is 0.32. And this gives us that our base is 40,000 divided by 0.32, or our B is $125,000. The different variations on this particular formula are all in section 2 for chapter 6. There is extra practice on that and the review exercises at the end of this section in your e-text. And with that, we do the third one. All right, so the third one is some business-specific problems involving percentages. Specifically, we're going to be looking at percent increase and decrease problems. We want to use specifically the portion is equal to the rate times the base for this one. So how do we find the portion, that is the amount of the increase or decrease? We need to know the original amount for any increase or decrease, and that goes in as our base. If we have an increase, we add the percentage rate to 100 because it's an increase, so it's going to be more than 100%. And if we have a decrease amount, we subtract that rate from 100 because it's going to be less than our original. Remember, the original is the base, and that's 100%. Then we solve this equation for the portion that we need. Okay, Amy, it's all well and good. Can you give me an example? Absolutely. Here we go. Here's our percent increase. We're going to find the portion. So, Affiliated Insurance estimated the number of claims for this year would increase by 15%. If the company received 1,800 claims last year, how many can they expect for this year? So the first thing we want to do is determine the original amount. Originally, they were comparing to last year. So last year will be our original amount of claims. And from the word problem, oh, I've got the wrong number. That should be 1,800. I wrote 1,600. Hold on. I hope I didn't do all the math wrong for this, but let's see. Let's do 1,800. Let's make that an 8. Okay, great. Now, is this particular problem a percent increase or decrease problem? Now that I've got the number fixed. If we refer back to the word problem, we see it is an increase of 15%. Since it is an increase of 15%, that means the percent that we want to use is 100% plus 15%, or 115%. At this point, I like to restate what's going on. What's going on is that we know that this year should be 115% of 1,800. 1,800. There we go, fixing it. Okay, so I am going to use the equation portion is equal to the rate times the base. And I'm going to plug in my numbers. So I've got portion is portion is not known. Rate is the percent as a decimal, or 1.15. And my base should be 1,800. Oh, it'll be interesting to see if I just wrote the wrong number down or not. So I'm going to take, sorry, I got my calculator because I need to make sure I'm right now. 1.15 times 1,800. Aha. And when I do that, I get 2,070, which means there would be 2,070 claims this year. So you can tell what I did, right? Like in my head, I switched to 1,600, but I still typed 1,800 into my calculator because, you know, these things happen. All right, so that's an increase. What about a decrease? Well, here's a decrease problem. The sweet shop, love that place, sold 7% fewer chocolate hearts this Valentine's Day when compared to last year. They sold 168 chocolate hearts last year. So how many does that mean they sold this year? So the original amount is what they sold last year. That's what I'm comparing the current to, is last year. So 168 is the number I'm using. Is this particular problem an increase or a decrease problem? Well, 7% fewer is a decrease. So we're going to decrease by 7%. That means that the percentage I'm using is going to be 100 minus the 7%, or 93%. So, as a restatement, I need to figure out this year is 93% of 168. What is it? What is 93% of 168? So, in order to make the equation, I need to know the portion, and that's going to be rate times base. My rate is 93%. My base is what they did last year, or 168. So I'm going to have 0.93 times 168, which when I calculate that out, I get 156.24. Now, the sweet shop cannot sell 0.24 of a heart. It's just not going to happen. So I need to round that down to 156 chocolate hearts. Yay? Okay. Now, how do we do this so that we find the rate? Again, we want to identify the new and the original amounts. In this case, it's going to be the percent or rate that's missing. So we're going to know how much there was exactly originally, and we're going to know how much there is in the new or the comparison number. So we need to identify each one of those numbers and find the difference. This will be the amount of the change, or the portion. We're going to substitute that in, using substitute the amount of change. Oh, okay. So we're going to use that. The amount of change is the portion and the original number as the base. And then we're simply going to solve this equation for the rate. Keeping in mind that that rate is going to be the percent as a decimal. So I'm going to have to multiply it by 100 as a final step. Okay. So here's one with a percent increase, and we're finding the rate. So Mark pays the gas bill in February, and it was $215. In March, the new gas bill is $275. Determine the percent of the increase to the nearest whole percent. So our original amount, oh, there's two amounts. Is the original amount the $215 or the $275? Well, if it's a time issue, it's which one came first. In this case, our original amount is the 215 because February comes before March. So we're going to use 215 as the original amount because on a timeline, February would come first. Now, is this going to be a percent increase or a percent decrease? Well, we're going from 215 to 275. So this is an increase. The difference is actually 275 minus 215, or $60. That means that we can recognize that that $60 is what percent of the original amount, and the original amount is 215. So 60 is what percent of 215. In order to set up the equation, one of the things you can use is the lovely magic triangle, where we are going to put a cover on the rate, which leaves us with portion over base. So rate is equal to the portion over the base. Our portion is the $60. Our base is the original amount of 215. So I will have 60 divided by 215, which gives us a 0.279069768. I need to multiply that by 100 and then round it to the nearest whole percent. So to the nearest whole percent, this is going to be 28%. All right. Same type of problem, but with a decrease. OTT, which by the way stands for on the top. On the Top Roofing completed 1,280 roofs in June and 1,210 roofs in July. Determine the percent change from June to July to the nearest tenth of a percent. Same basic steps. I'm going to make sure I'm clear on the original amount. Now, again, there are two amounts here, so the original amount would be the one that comes first. Not necessarily in the word problem, but the one that comes first in a timeline. Since June comes before July, I'm going to use 1280 as my original. Now, is this a percent increase or is it a percent decrease? Since we started at 1280 and it goes to 1210, this is clearly a decrease. That decrease would be the difference between the two numbers, or 1280 minus 1210, which is 70. So now we need a statement. I like to restate, just quick and easy. I know, another number error. 70 is what percent of 1280? Oh man, there we go. 70 is what percent of 1280? Since I have the portion and the base, and I'm looking for the rate, I'm going to use the lovely little triangle, put my thumb on top of the rate, and I see that rate is equal to portion over the base. So that's going to be 70 over 1280, which when I divide it out, I get 0.0546875. To convert this to a percent, I'm going to multiply by 100, which is going to give me 5.46875. And then that 6, well, I need to round to the nearest 10th. So that 6 is going to round that 4 up to a 5, and I'm going to end up with 5.5%. All right. Now, the last one here is probably the most hardest to recognize and sometimes the most difficult to find. So these we're going to do when we have a base missing. So what happens if you don't know the original amount? What happens if you're only given information like housing market is up 10% from last year? The average cost of a house this year is $160,000. Well, that doesn't tell me what it was last year. So how do I go backwards and find what it was last year? So this is finding the original amount or the base. So in order to do this, we need to recognize that new amount and the percent. We've got to be able to find both in the problem. So the percent, if it's an amount off, you will need to subtract it from 100. And if the percent is an additional amount, like in a raise, you would add it to 100. Make sure that you substitute in those values. The new number is going to be your portion. The rate, again, will be a percent as a decimal. And then you'll solve the equation for the original amount, making sure that you divide both sides by the rate, or putting it into the formula, base is equal to portion over rate. So here we go. I've got two of them here. The first one is dealing with an increase. So Kim paid $2,316.10 in property taxes this year. This is a 6% increase from last year, and we want to determine the amount she paid last year. So we want to determine the original amount. The problem is we don't know that. We don't know what the original amount is. That's what we're trying to find. We don't know it. So is this a percent increase or is this a percent decrease? Well, it says this is a 6% increase. So we know it's an increase. That means that the new amount is the old amount, 100% plus 6%, or 106%. So can we sum up our information? Our statement here is that the $2,316.10 is 106%. I forgot my 10. I wonder if that'll make a difference. There we go. Is 106% of what base? What original amount? So when we're looking for the base, if you're using the magic triangle, you're putting a finger or a tip of a pencil on the B for base, and you get that the base is the portion divided by the rate. So that's 2,316.10. There we go, 1610. I bet my answer is wrong then. Divided by 1.06. I bet I'm off just ever so slightly. Let's see what happens. 2,316.10 divided by 1.06. Yeah. All right, and so when I do that, I should get, I made it work out even, 2,185. So I'll need to fix that up. So 2,185. I mean, not that it makes a big difference. It's essentially the same. But notice that even 10 cents makes a difference. I might not have thought that originally. 2,185. Okay. All right, great. I'll fix the original PowerPoints on this. Okay, percent decrease. Same idea, finding the base given a decrease. A recent report on housing showed that for the first time in decades, the size of a new house had shrunk by 18% to 1,722 square feet. What was the original square footage of the average home? So we're no longer doing McMansions. We want to determine the original amount, which, by the way, we don't know. That's this type of problem. What was the original square footage? It's right there in the question. We don't know what it is. Is this going to be a percent increase or a percent decrease? Well, the size of a new house shrunk. Shrinking is not an increase. Shrinking is indeed a decrease. And if it's a decrease, that means the percentage should be subtracted. So our original is going to be 100% minus the 18%. Or 82%. Man, Amy, the math errors in this one. 82%. Okay. Now, this gives me our statement, which should read 1722 is 82% of what base? I bet this whole one is wrong. Okay, 1722, which is our new amount. It is 82% of what original amount? So our equation means I'm looking for the base, so I'm going to cover up that B for base, and that means I'm left with portion over rate. So base is the portion over the rate, which is going to give us 1722 divided by 0.82. Let's get that right in there. And now I'm going to need my calculator because I had the wrong number in there. 1722 divided by 0.82. Which is going to be 2100. Oh, 2100. Okay, so that means that our final answer here is 2100 as the original square footage. Let me fix that guy. 2100 is our original square footage. Now, this is should be section 3 in chapter 6. Lord, I cannot keep it together today. There we go. Section 3. Your review exercises are available in your e-textbook at the end of section 3 for some extra practice. There is a graded assignment covering this material. All 3 sections are covered in one assignment in chapter 6 on WebAssign. The name of the assignment is chapter 6. I believe it might even say chapter 6 percentages, but that is the name of the assignment. As always, if you need assistance, please contact your instructor, your embedded support personnel, the math center, or tutor. We are all here to help you and happy to do so. As a side note, I will be fixing the original PowerPoint, and maybe someday I'll put up a whole new video. Thanks. Have a good night.